Okay, does this work? Yes. So I'm gonna show you how references work in C++. References are kind of like aliases for existing variables or nicknames or the second name for it, however you wanna think about it. But for example, we have memory here, we have allocated one memory to this integer variable which names is num1, and we have stored number 1 here. So now we have that. For example, we can make a reference to this memory location by writing this kind of code. We say the data type which we want to reference, then this ampersand symbol, then the name of the new reference variable, and we just assign it to that variable which we wanna reference. So now after this line, the ref is basically just the same as num1. So we can change the contents of that location by changing that ref, changing this ref. So it's basically like ref, we just put, we now have two names, we can call it num or ref, and we can change the contents there by, for example, ref is 2. Now this line makes this 1 goes over and we put the 2 in there. Now there's 2. That's kind of like reference. I can show you on paper better. So why do we need two names for the same variable? They're not that useful when normally making them, or at some cases it might, but mostly they are used in function parameters. So when a function is called, it usually takes some parameter, but this parameter is normally a value parameter. So it basically copies the value here, and now it uses the copy inside the function, and it destroys the copy after the function has been executed. For example, when we assign this num to 1, and when we call the function with the num, it goes here, but it copies the value num1 to here to number we assign it 2. It doesn't change the num1, it only makes this 2, and it destroys the number variable here. So it doesn't change. It's when we print the num1 here after the function call, it's still 1. And that's basically like a normally called function. But we can change the function parameter to reference, and then we can actually use that variable inside the function, or reference it inside the function, and it changes the contents of the parameter we called it with. So for example, num is now 1, then we call the function with the num1, which is 1. It goes here, but it doesn't copy this here. It creates a new name for this num1 here. So this is like a new name, interref. Now the ref points to this same memory location. It just has so when we change the ref to 2 inside the function, it destroys the ref. Doesn't matter, the num is already changed because the ref changed the num1 also. So now after the function call, we can print the num1, and it prints 2 because the reference changed it. So that's like the most useful way of using references. And if we have a bigger data type or data structure we want to pass as a parameter to a function, it's usually better to call it a reference, because we don't want to copy every time we call the function. We don't want to copy the existing data structure here to the function, because it takes a lot of memory if the data structure is big. So that's basically it. If we want to use the big data structure, but we don't want to accidentally change anything in it, we can make a const keyword at front which makes it a constant value. So for example, if we try to change the ref here inside the value, because it's const, it crashes the program if we try to change it. So it's kind of like a helpful way of knowing that it's impossible to change. If we print the ref, that's like the most useful case for const references. But yeah, we can only print and do other stuff, but we cannot change it. Okay, that's basically it.